Today we cover section 13.1 on measures of central tendency. For any set of n numbers, x of 1, x of 2, x of 3, all the way out to x of n, there are three common measures of central tendency. The first is called the mode. The mode is simply the most frequent number in the set of numbers. For example, if I gave you the list of numbers 3, 3, 8, 3, 1, 5, 8, 8, 8, the mode would be 8 simply because 8 appears 4 times and no other number in that list appears that many times. However, if two numbers appear equally frequently, we call both of them modes, and for a case like this, we say that the set of numbers is bimodal. For example, if I ask you to find the mode of this set of numbers, 7, 7, 2, 7, 1, 5, 2, 2, you'll notice that there are 3 2's, but there are also 3 7's. So we'll call them both modes, and that's an example of a bimodal set of numbers. If 3 or more numbers appear equally frequently, we say the set of numbers is multimodal. For example, if I ask you to find the mode of the set of numbers 1, 2, 2, 5, 4, 3, 5, 3, you'll notice that 2 appears twice, 3 appears twice, and 5 appears twice. So there are 3 modes, 2, 3, and 5. The mode is not affected by outliers. That means that a single value that's way larger than most of the others or way smaller does not really affect the mode at all. In fact, the mode can even be used for non-numerical values. The second common measure of central tendency is called the median. The median is simply the middle number in value. If I ask you to find the median of the set of numbers 3, 3, 8, 3, 1, 5, 8, 8, 8, the simplest thing to do is put the numbers in order because you can't find the middle number in value easily unless the numbers are ordered. So if I list them from small to large, I get 1, 3, 3, 3, 5, 8, 8, 8, 8, and from that you can see that 5 is the middle number with 4 numbers to the left of it and 4 numbers to the right of it. So the median is 5. But there can be a case where there is no single number in the middle. What do you do then? If I gave you the list of numbers 3, 3, 8, 3, 1, 5, 8, 8, 8, 9, now when you put the numbers in order, you get 1, 3, 3, 3, 5, 8, 8, 8, 8, 9. And there's no single number in the middle. 5 and 8 are the two numbers closest to the middle. And when that happens, you simply average the two middle numbers. You take 5 and 8, add them up, divide by 2, and you'll get 6.5 in this particular case. You only do that when there's no single value in the middle. So in this case, the median is 6.5. Note that the median is also not affected by outliers. A really big value or a really small value doesn't affect the median at all. For example, the median for the list of numbers 1, 2, 3, 4, 5 is exactly the same as the median for the list of numbers 1, 2, 3, 4, 50. That big outlier, that 50, does not change the median at all. The third common measure of central tendency is called the mean. The mean is the ordinary arithmetic average of a set of numbers that you've been using for years. But I do want to talk about the notation. We call that X bar. X with a horizontal bar above it is the standard symbol for the mean. And you'd read that X bar. X bar is simply the sum of the values divided by how many there are. That's the ordinary average that you've known how to do for years. There is another notation, though, that you'll see in mathematics. It's the capital Greek letter sigma. And that sigma x sub I divided by n is just another way to write the mean. And the sigma itself means sum. So it's all that's telling you to do is sum up all the x's and divide by n. So when you see that sigma, think sum. Technically in statistics, X bar is the sample mean. If you draw a random sample from a population, mu represents the mean of the whole population from which you drew the sample, while X bar denotes the mean of the sample that you drew from the population. Because we're not focusing much on inferential statistics in this course, the difference between these two things isn't terribly important to us here, but technically X bar is the sample mean, mu is the population mean. But like I said, for what we do in this course, it doesn't much matter. How about this example? Find the mean of the list of numbers 3383158888. Round the answer to 2 decimal places. All you do is add up the numbers and divide by how many there are. In this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. When you add all those numbers up, you get 47, so you divide 47 by 9, and rounded to 2 decimal places, you get 5.22. How about this? To get a B in math, Alexandria Pappas must average an 80 on 5 tests. Her scores on the first 4 tests were 84, 77, 81, 76. What is the lowest score she can get on the last test and still get a B? Very straightforward, but how do you do it? I know that when I average grades, I just add them all up and divide by how many there are. And if I want to get a B, or if she wants to get a B, that average has to come out to be 80. So just take the scores of her test, 84, 77, 81, 76, plus this last score, which is unknown. You can call it X, or you can just write last score like I did. The sum of those 5 divided by 5 has to be 80 if she wants to get a B. So now if you add up those 4 numbers in the numerator, you get 318. So 318 plus the last score divided by 5 must be 80. If you multiply both sides of that equation by 5, the 5 in the denominator on the left cancels out, and you get 318 plus the last score is equal to 400. And if you subtract 318 from both sides, you'll find out that the last score must be 82. So Alexandria needs to get at least an 82 on that last test in order for her to get a B in the course. Let's look at the grades of another student. Joe has an average of 80 based on 5 test scores. Before he took his 5th test, his average based on his first 4 tests was 79.5. What must Joe's test 5 score have been? The average was 80 based on 5 test scores. So when you're taking an average, you add up the scores and divide by the number of scores. So we'd add the test scores, divide by 5 because there are 5 of them, and we want that to be 80. If you take that and get rid of the fraction by multiplying both sides by 5, you can see that the sum of the test scores must be 400. So we know that. What else do we know in this problem? We also know before he took his 5th test, his average on his first 4 tests was 79.5. We can play the same game. We know how to average. If we average his first 4 tests, it comes out to 79.5. So if you add up those first 4 tests, divide by 4, you set it equal to the average of 79.5. And again, if you want to clear the fractions by multiplying both sides by 4, you'll find out that the sum of the first 4 test scores must have been 318. Well, if you look from left to right or right to left, you can see that there's some commonality. On the right, you know that the sum of the first 4 test scores was 318. So you can take the sum of the first 4 test scores on the left and replace it with the sum of 318 because you know that from the right-hand side. So putting 318 over there in place of the sum of the first 4 scores, that tells me that 318 plus the test 5 score has to be equal to 400. And if you subtract 318 from both sides, you'll see that the 5th test score must have been 82. So a little bit of algebra, but if you think it through, looking at the information the problem gives you, it's really very straightforward. How about this one? Let's look at the grades of a 3rd student. Anne has test scores of 61, 24, and 85. In this class, the lowest test score is dropped. What score does Anne need on test 4 to raise her average to 75, incorporating that test drop? Well, again, just read through the problem. We're looking for the test 4 score, so we'll let a variable stand for that, and I've been using capital T's for the test score, so I'll call T sub 4 Anne's 4th test score. So that means her test scores are 61, 24, 85, and this unknown test 4 score. We're dropping the lowest score, which would be a 24, and averaging what remains. So what remains are the 61, the 85, and that unknown test 4 score. We want her average to come out to be 75, so if you add up 61, 85, and that unknown test 4 score and divide by 3, that'll give you the average, and you want that to be 75. So when you set that equal to 75 and clear the fractions by multiplying both sides by 3, you'll find out that 61 plus 85 plus t sub 4 is 225, and if you add 61 and 85, you get 146, and subtracting that from both sides, you find out that Ann would have to score a 79 on that test 4, in order to raise her average to 75. This might be a good time to mention that this Casio FX260 solar calculator that we use has a stats mode that you can use to calculate means for you so that you don't have to do the work the long way. I'm going to show you how to do this, and this is something you need to learn because it's extremely useful. The first thing you do is to press the on key. Not only does that wake the calculator up, but it also clears out any old data. And that's important because if you are doing a calculation and you don't realize there's already data in there, it can mess you up. So press on, that wakes the calculator up and clears out any old data. To put the calculator in stats mode, you press the mode key and the dot or the period key. That puts the calculator in stats mode. Mode dot. When you put the calculator in stats mode, in the upper right hand corner, you'll see the letters SD. Upper right corner of the display. If you don't see that, the calculator did not go properly into stats mode. So after you press mode period, look for that SD in the upper right hand corner. Assuming you see that, now you key in the first number. Whatever the first number in the list, you key it in. Then you press M+. M+ is like the enter key for the data that goes into stats mode. And then you just key in each number until you get them all in, one after the other. You have to press M+ after each one. Be careful though, some people forget to press M+ after the last number. If you don't press M+ after a number, it is not entered into the stats mode. After you get all the data in, press Shift 7, and you'll notice on your calculator that you don't have to memorize that it's Shift 7, because if you look above the 7, you can see that X bar symbol. It's right above the 7. And when you do that, the calculator display will show you what the mean is. That's all there is to it. There are a couple of other useful tips I'll mention. If you press Shift 6, it'll show you how many numbers you've entered, and that can be useful because if you're typing in a list of say 10 numbers and you accidentally miss one, or if you accidentally enter one twice, one way to catch that is by pressing Shift 6. If it doesn't come up with the right number of numbers, you know there's a mistake. Also, once a number is entered, if you press M+, it enters the number again without you having to actually type the number in. And also, there's a summary sheet. If you bring up the PowerPoint that this video is based on, there's a hyperlink here that takes you to a summary sheet that tells you all these things, and it might be a nice thing for you to bring up on your computer and print out. In any case, let's get back to actually calculating means using the calculator, the Casio FX260. Suppose I want to find X bar for the data set 18, 15, 11, 31, 32. What do? Step 1, press on. That wakes the calculator up and it clears out any old data that might be in there. Then you press mode period. That puts the calculator in stats mode. Always look in the upper right hand corner and make sure that SD popped in there. If it didn't, you're not in stats mode. Once in stats mode, you key in the first number and press M+. So in this case, 18. Then you press 15 and hit M+. And then you press 11 and hit M+. Then 31 M+. Then 32 M+. After you entered all the data And again, don't forget to press that last M plus after the 32. But once all the data is in, press Shift 7. And in the calculator display, you will find the answer. Just throw these useful tips up here again, same ones I mentioned earlier. But let's see what you get. The keystrokes for that problem would be on, it clears the old data, mode, period, puts it in stats mode, 18M plus, 15M plus, 11M plus, 31M plus, 32M plus, that enters the data, and then Shift 7 gives you the mean, which turns out to be 21.4. I mentioned earlier that the mode and the median are not affected by outliers. The mean, however, is. It can be strongly influenced by outliers. And if you don't believe me, try it yourself. Take the mean of 1377 and then take the mean of 13750, and you'll see how much difference that one number 50 makes to the mean. Doesn't change the mode, doesn't change the median, but the mean is highly sensitive to outliers. Sometimes you'll be asked to calculate a mean, median, or mode from data that's presented in a frequency table. So let's look at that case. Suppose I give you a table with a bunch of scores. The scores are listed in the left-hand column, and then there's a frequency column which tells you how many times that number appears. So 12 appears once, 15 appears once, 17 appears 3 times, 20 appears 3 times, 21 appears 1 time, 26 appears 4 times, and 32 appears 2 times. Because a frequency table already has counts, it's easy, super easy to find the mode from a frequency table. You just find the score with the largest frequency. Here, there's only one value that appears 4 times. Nothing else appears more than 3 times, so the mode is 26. So a frequency table is perfect for finding modes. The median, you have to look at the numbers listed in order. So first of all, as long as the table has the values in order, like 12, 15, 17, 20, 21, 26, 32, as long as those scores are in order, it's pretty easy. Now, if you look at the sum of the frequencies, 1 plus 1 plus 3 plus 3 plus 1 plus 4 plus 2, you'll find out that's 15. So there are 15 scores. If there are 15 scores, think about it, the 8th score must be the middle score. 7 on the left, 7 on the right. The 8th score is going to be the median. So what's the best way to find the median? I would just start, assuming that the table gives the numbers from smallest to largest, like this one does, I would just start at the top and count. 12, that's 1. There's only one of them. If you go to 15, there's only one. So 12, then 15, that's 2 things. Then you move down to 17. There are 3 of those. So the 3rd number in the list is 17. The 4th number in the list is 17. And the 5th number in the list is 17. Then you keep going. You move down to the 20s. There's 3 of those. You've already counted 5 numbers, so the first 20 is the 6th one. The second 20 is the 7th one. And the third 20 is the 8th one. Well, remember, the median was the 8th one, so the median is 20. You could keep going and list them all, but you only want the median, so once you hit the median, you can stop. So the median is 20. See how that works in the table? It does assume, and you got to be careful, that the numbers actually are in order. If they're not, you've got to put them in order. So here the median is 20. You could have actually, if the numbers aren't too large, you really could have just listed them all out. So if you wanted to write 12, 15, 17, 17, 17, 20, 20, 20, 21, 26, 26, 26, 26, 32, 32, you could, and you could have found the median that way. But you really don't want to go to that much trouble. It's much easier just to go down using the table and count till you get to the middle value. What about the mean? Well, it's easy enough to do it with your calculator. The first thing you want to do is wake the calculator up and clear out the old data if there is any. And you do that by pressing on. Then you do mode period. That puts it in stats mode. Always look in the upper right and make sure SD comes up. And then you enter the data. There's 112, so you do 12M plus. There's 115, so you do 15M plus. But there are 3 17s, so you type 17 and hit M plus 3 times. Then you go to 20. There are 3 of those, so you type in 20 and then hit M plus 3 times again. Then you go down to 21. There's only 1 of those, so you press M plus once. Then you go to 26. There are 4 of those, so after you type in 26, you hit M plus 4 times. Then you go to 32. There are 2 of those, so after you type in 32, you hit M plus twice. And once you get all the data in, you do Shift 7. And once you do Shift 7, the calculator display will give you the answer. And in this case, it's 21.8. So the mean is 21.8. Now let's talk about something called a weighted average. When some values are more important than others, we use a weighted average. The table below shows Dylan's fall semester course grades. Use the weighted mean to find Dylan's GPA for the fall semester. An A is worth 4 points, a B is worth 3 points, a C is worth 2 points, a D is worth 1 point, and F is worth 0 points. The table shows you the courses in the first column, the course grades in the second column, and the course units, which are basically just credit hours for each course, in the third column. The first thing you'll want to do is get rid of those letter grades and put in their numerical equivalents. So a B is worth 3 points, an A is worth 4 points, a D is worth 1 point, and a C is worth 2 points. Once you've done that, you look at that table. The course grades, now that they've been changed to numerical values, are what we're trying to use to calculate the GPA. The course unit column are the weights. It tells us, for instance, that a 4-hour English course is worth more and weighs more than a 3-hour history course, and so on down that list. So the course units represent the number of credit hours for that course, and those represent the weights. The second step is to add up all of the weights, that being the course units. 4 plus 3 plus 3 plus 4 is 14. So Dylan is taking 14 credit hours this fall semester. Next, you want to multiply each value, the course grade, by its weight. So you get 3 times 4 in the first row, that's 12. 4 times 3 in the second row, that's 12. 1 times 3 is 3 in the third row. 2 times 4 is 8 on the fourth row. And then you want to add those products up. 12 plus 12 plus 3 plus 8 is 35. And finally, you take the sum of the products in that product column, the last column, and divide by the sum of the course units. In other words, the sum of the weights. So the GPA is 35 over 14. If you divide that out, you get 2.5. So Dylan had a 2.5 GPA in the fall semester. I will say that if you want to work this problem as if it were an expectation problem from the previous section, you can do that. All you have to do is change the weights to percentages. So if you take those course units, which represent the rates, and make them into fractional percentages, in other words, English is worth 4/14 of the grade, history is worth 3/14 of the grade, chemistry is worth 3/14 of the grade, and algebra is worth 4/14 of the grade. In other words, divide each course unit value by the total of the course units being taken. That basically changes that course unit columns into a percentage column. At that point, it's just like an expectation problem that you worked back in the previous section. So in the previous section, you learned that you could multiply across, multiply across, multiply across, multiply across, and then add. And when you add all those fractions, you end up with 35/14, which is the same thing we got before. You get exactly the same answer. So I'm not advocating that you do it that way. I'm just saying that if it makes sense to you to think of these weighted averages as just an expectation problem, you can do it that way. all you have to do is first change the weight column to percentages. It's up to you which way you want to do it. Now let's take the Dylan example and push it forward into the spring semester. Suppose Dylan's spring GPA was 3.4 on 16 course units. In other words, he actually did better in the spring than the fall. He had a 2.5 in the fall. Well, he got a 3.4, much better in the spring. And he was taking more credit hours too. He was only taking 14 credit hours in the fall. Now he's taking 16 credit hours. So I want to figure out Dylan's cumulative GPA for that whole academic year, the 2 semesters together. If he had taken the same number of credit hours both semesters, all you would have to do is average the 2 numbers. But because he took more hours in the spring and the fall, you must treat this as a weighted average. So what we're going to do is treat the GPAs as the values, the 2.5 and the 3.4, and the weights will be the credit hours, 14 and 16, and make a table. So one column are the values. Those are the actual GPAs, 2.5 and 3.4. And the credit hours are 14 and 16. So Dylan had a 2.5 GPA taking 14 credit hours in the fall, and he had a 3.4 GPA taking 16 hours in the spring. Then you want to take the products, 2.5 times 14 and 3.4 times 16, and that gives you 35.0 and 54.4. Then you want to sum up the products. That's 35 plus 54.4, that's 89.4. Then you want to sum the weights. In other words, how many credit hours altogether was he taking? That's 30, 14 plus 6. And finally, the GPA is going to be the sum of the products, which is 89.4, divided by the sum of the weights, which is 30. So Dylan's overall academic year GPA for the fall and spring together was a 2.98. Let's look at this problem. In Rita's math class, quizzes are 40%, homework is 20%, attendance is 5%, and the final exam is 35% of the course grade. At the end of the term, her quiz average is 82, her homework average is 93, and her attendance average is 95. What score does Rita need on the final to get a course grade of 90%? And round your answer to 2 decimal places. This is another weighted average because things count differently. The quizzes are 40%, the homework's 20%, and so on, so they're not equally weighted. My recommendation with the weighted average problems is to do it by table. You need to list in a column all the things that make up the course grade: quizzes, homework, attendance, final exam. I did that in the first column. Then you need a column for the actual grades that Rita made. Those are what I call the values when we're doing weighted average. You need a column for the weights. That's the percentages that each part of Rita's grade is worth. And then we'll have a products column, which is sort of an intermediate calculation column. So using that as an organizing way to do a weighted average makes sense to me. In any case, the first step is to add up all the weights. So I'll put those weights into the weight column: 40% quizzes, 20% homework, 5% attendance, 35% final exam, and then add the weights. You always sum the weights. It turns out that these weights add up to 100, and that makes sense in this context because that's 100% of your grade. We want to know what score Rita needs to make on the final to make that course average 90. So when we're listing the grades, which is the next step, put in the grades, we want to put a variable in for that unknown score. I just called it F. Rita's quiz average was 82, her homework average was 93, her attendance average was 95, and that unknown score for the final, we'll just call it F. So I want to multiply every value by its weight. That's the nice thing about the table. It makes these calculations easy to do. So I multiply across left to right. So 82 times 40, 93 times 20, 95 times 5, and F times 35, and put those products in the product column. Next, I want to add up those products. So if you add up 3,280 1,860, 475, and 35F, you get 5,615 plus 35F. Now the last step in doing a weighted average is to divide the sum of the products by the sum of the weights. In other words, the number at the bottom of the last column divided by the number at the bottom of the next to last column. And that quotient gives you the weighted average that you're looking for. So in our case, that would be 5,615 plus 35F divided by 100 is equal to the average we want to come up with, which is a 90. And if you multiply both sides of that equation by 100 to get rid of the fractions, you'll end up with 5,615 plus 35F is equal to 9,000. Then subtract 5615 from both sides and divide by 35, and you'll find out, rounded to 2 decimal places, that Rita would need to make a 96.71 on her final to get a 90 average in the course. The table is my favorite way to organize the calculation, but if you really understand this, you don't have to build a table. I'm just going to throw up the calculation that you would do if you didn't just wanted to do it and didn't want to take the time to build the table. It's always a quotient, and in the numerator, it's a sum of products. And I used red and green. The red numbers are the values. Those are the actual grades that Rita made. The green numbers are the weights. So in the denominator of the fraction, you always sum up the weights. In the numerator, it's the sum of the products. You take each weight times the score that the student actually made, take those products, add them up, and that gives you the weighted average. And because we wanted that weighted average to be 90, that's why I set it equal to 90. And then you just do the calculation pretty much the way we did earlier. But the table is a way of organizing that calculation. If you really understand it well, you can dispense with the table and just write out the equation directly. It's totally up to you.